In this tutorial, I'll show you how to perform Pearson correlation in SAS. First of all, open up your Google Chrome browser and navigate to SAS Studio. Next, you'll want to find the data that we're going to be using for this tutorial. So go to your My Courses folder. Within that, you should see a PH205B folder, and within that, a Tutorials folder. You'll find the test scores dataset here. Copy it into your class.dat folder by right-clicking on it, selecting Copy To, selecting class.dat, and clicking Copy. Once you've done that, do the same thing for the Pearson correlation tutorial code. And once it's in your class.dat folder, you can double-click on it and you'll have the code to follow along with this entire tutorial. Next, run your libname statement. Remember to replace my username with yours. Highlight it, click Run. You should see a message with no red in it. Our research question for today is there a correlation between reading score and math score? In the codebook for this data set, you'll see that there are two variables: read score, which is the score on the reading portion of a standardized test. It is a scale variable, and the math score likewise is the score on the math portion of the standardized test, also scale. So the first thing you want to do is go to SAS and check the data set to see how many observations are in it and to make sure your variables look okay, to make sure they look like scale variables. So you'll click on your data set over here, your test scores, double click, and we can see that there are 30 total rows, which means there are 30 observations, which we can see here. And it does indeed look like read score and math score are scale variables. They are numbers measured as a single number along a continuum. Now you can close out of your data set. You can expand your programming window. And the next thing we want to do is run descriptive statistics with normality tests. Anytime we run descriptive statistics from now on for a scale variable, we will also want to compute a normality test. We're going to use the proc univariate command to run descriptive statistics with normality tests for these scale variables. So proc univariate data equals our library dot dataset name, normal. Then our variables that we want to test are read score and math score. We want to create a histogram for each of those so we can look at them graphically. Highlight that and click Run. What we're most interested here is first this table of descriptive statistics. This is for read score. And next, the table that shows us the tests for normality, along with our histogram. So here's the distribution of read score. So in terms of normality, if we want to know whether this variable is normal or not, we can either look at this skewness and kurtosis, and if it is between -2 and +2, we can say the variable is normal, and it looks like both of these numbers do indeed fit that description. Or what's even a little easier is we can look at the p-value for the Shapiro-Wilk test. So it's down in our tables for normality down here. And this is the p-value for the Shapiro-Wilk test. If it is not significant, the variable is normal. If it is significant, that is, if it is a very low value below alpha, that means the variable is not normal. So it looks like read score is a normal variable. Let's go down to math score. Let's take a look at its distribution. We have 30 observations. Skewness to kurtosis look like they are between negative and +2, and the Shapiro-Wilk p-value is not significant. So both of these variables look normal. Now we can go back to our code. And the next thing we want to do is choose a correlation test based on the info that we garnered from our descriptive statistics. So we have two scale variables and equal to 30 observations. So let's choose a Pearson correlation test. The next thing we want to do is we want to state our null and alternative hypotheses and state our significance level. The null hypothesis for a correlation test is that there's no significant correlation between the variables. The alternative hypothesis then is that there is, and we'll set our alpha value at 0.05. Next, we want to conduct this test and create a scatter plot. To conduct the Pearson correlation test, we use the command proc core, and then plots equal matrix. And this lets us actually create this scatter plot along with the test. So we don't have to create a separate scatter plot. The test here will create it. And then these are the variables within our test. It doesn't really matter what order they're in. So highlight that and click Run. And now we have to take a look at the scatter plot to make sure the relationship between read score and math score is approximately linear, because that is one of the assumptions for a Pearson correlation test. And here we can see we could probably draw a straight line right through this, so it looks pretty linear, so that assumption is met. Since that assumption is met, we can go back up to this table, the Pearson correlation coefficients, and we can interpret the results here. It's a symmetrical matrix of results. So the correlation between math score and read score, and this correlation between read score and math score. So the correlation coefficient is the top number here, the 0.98947, and the bottom number is the p-value. And our results show here that our p-value is below alpha, which was 0.05, so this is indeed a significant result. Now we can interpret the direction and the strength of the correlation coefficient. So 0.98947 is a positive number, so it looks like the direction is positive. And the strength, well, if we look at our little table of weak to strong correlations, we know that 1 is a perfect positive correlation. This is pretty close to 1, so we're going to say this is a very strong correlation. And how will we interpret it then in a sentence? We would say there's a strong positive correlation between reading score and math score, and then we would include our Pearson's R and our p-value at the end of the sentence. So in summary, in this tutorial we conducted a Pearson correlation test in SAS. First, we computed descriptive statistics to make sure that the data met the assumptions of the test. The assumptions of the test are that the sample is random. We're just going to assume that. Secondly, both variables are measured at the scale level. That was true. At least 30 observations. That was true. Or both variables normally distributed. So we've covered our bases there. And then finally, a linear relationship between variables, which we saw on the scatterplot matrix when we computed the correlation coefficient. So that's it for this tutorial. Bye, everybody.